Hello friends, we are from group 7 here for short presentation 2 on the topic of K nearest neighbor. Our team members are Nitish Reddy, Trilok Vadineni and Tarun Sai. As I told you about, our topic is about K nearest neighbor. It is a supervised learning algorithm which is developed in 1951 by Elvin Fix and Joseph Hodges. Later it was developed by Thomas Cover. It is used for classification and regression. Nearest neighbor algorithm is also known as lazy learner's algorithm. It works by finding the distance between a query and all the examples in the data, selecting the specified number of examples closest to the query, then votes for the most frequent label or averages the label. For example, imagine a computer is a child. We are its supervisor and we want the child to learn what a pig looks like. We will show the child several different pictures, some of which are pig, and the rest could be pictures of anything. And its working process will be like we will load the data, initialize it, and calculate the distance between the query example and the current example from the data. Later on, we will sort it. Later, pick the first k entries from the sorted collection, and we will get the labels. If the regression return means of the k value, and later if classification return the model of the k labels. Later my friend Tarun will continue the rest of the PPTs.
Hi, now we can see the example of a two data sets, category A and category B, that are present. So consider a new data is entering between the two data sets. So now we need to decide on which data set does the new data set belong. So we are using the k nearest neighbor for this. So according to the k nearest neighbor, the data set which it belongs nearest to the already existing data set. The new data set belongs to the old data set. So according to the k nearest neighbor, the new data set is nearer to the category A. So the new data set belongs to the category A. So for this calculation of distance, we use mainly two types of formulas. They are Euclidean distance and Manhattan distance. Coming to the Euclidean distance is calculated as a square root of sum of the square differences between the new point and an already existing point. Coming to the Manhattan distance, this is the distance between the real vectors using the sum of their absolute differences. Here we can see the pseudocode of the k nearest neighbor. It's a pseudocode in Python, and we can see these are the first three lines are already predefined functions in the Python, and the rest are the reading the inputs and deciding which are the training data sets. So coming to the time and space complexity, the time complexity is nothing but the total time taken by the algorithm to execute the program. And coming to the space complexity, it is the total memory occupied by the algorithm while executing the program. So coming to the k nearest neighbor, the time complexity is O into n into d, where n represents the number of data points and d represents the number of features that determine each data point. And coming to the space complexity, it's actually the same O into n into d. So these are the areas where the most k nearest neighbor is used, especially in the credit rating agencies, and they are used in loan approvals, and they are especially used in pattern recognition, stock price prediction, and many more. Now my friend Nitish will explain.
Oh, hello all. This is Nitish. Now I'm going to explain about the advantages and disadvantages of the k nearest neighbor. Coming to the advantages, the algorithm is simple and easy to implement. It is a no training period. Since the k nearest neighbor is called as a lazy learner, it does not learn anything in the training period. It can be used for the both classification and the regression problems. It's ideal for the nonlinear data since there is no assumption about the underlying data. Since the K nearest neighbor algorithm requires no training before making the predictions, new data can be added seamlessly, which will not impact the accuracy of the algorithm. It can naturally handle the multi-class cases. It can perform the well with the enough respective data. K nearest neighbor is a very easy to implement. There are only two parameters required to implement the K nearest neighbor, the value of K and the distance function. Coming to the disadvantages of the K nearest neighbor, it does not work well with the large data set. The algorithm gets significantly slower as the number of examples and the predictors independence of variable increases. Associated computation cost is high as it stores all the data, training data. It does not work well with the high dimensions, requires a high memory storage, needs to determine the value of K, need the feature scaling. We need to do the feature scaling before applying the K nearest neighbor algorithm to any dataset. If we don't do so, K nearest neighbor may generate the wrong prediction. Prediction is slow if the value of the N is high. Sensitive to the noisy data and the missing values and the outliners, K-nearest neighbor is sensitive to noise in the dataset. We need to manually input the missing values and the remote outliners, sensitive to irrestrictive features. Coming to the questions, what is the other name of the K-nearest neighbor? Option A, weak algorithm. Option B, lazy learner algorithm. And option C, regression algorithm. Coming to the question 2, under which of the following category does the K-nearest neighbor algorithm belongs to? Supervised machine learning algorithm, unsupervised machine learning algorithm, classification algorithm. Coming to the question 3, how can we measure the distance in K-nearest neighbor? Euclidean distance, Manhattan distance, all the above. Thank you all.